Welcome to a new test and teardown video. This time it's another Hewlett-Packard 54610B oscilloscope, 500 megahertz. Really? It's 2 channels and it's all digital. And it is in a beautiful, beautiful state. Look how close to new condition. So that is absolutely fantastic. We also got this front cover, and it has seen a little bit better times. Some tiny little, I think it is from about 1993, because here in the manual, there we go. So the manual is from 93, and then the manual is just absolutely fantastic. I totally love it. I don't have the manuals for all the different units I get in, but this time I'm so happy to see the manual, and it is in a mint condition as well. I've been having a little bit of fun to read a little bit around in this manual. There will be a few things I probably want to show, especially about its performance when it comes to all the many megahertz they say it can do. Yeah, let's try and power it up, because I was promised this one should work, so we should, of course, just plug it in and enjoy the greatness of 93. There is a plug-in module here. Oh, the screw is loose. So this is the HPIB interface. The connector is right there. It's also called a storage module. And then here at the back we got this DC calibrator output, and I think it is in protected mode, so that is good. It looks like it was dropped, but I hope the fan is all right. So I just plugged in mains, and it is using exactly 0.0 watts. So I believe the mains switch disconnects everything, and it's using about 60 watts at the moment, and it boots off perfectly fine. And it's also 94 here on the software. And there is a nice and sharp picture. See, here's brightness. I don't need to have it more bright than this. It's just because I have a lot of... let me turn this off like that. The fan is not super silent, but it's also not really driving me nuts. So that will be channel 1 off, channel 2 on off. And see there, I don't know if this is super visible on the video, but there's a quite alright response. And this is very important when you're working with a scope. When you dial something, you should see a response immediately. That is really important. Yeah, let's try and input some signals. So let's try and do this super simple. I want to put in something on channel 1. Just plug this into my signal generator and hit auto scale. And there you have it, a super nice 1 kilohertz signal. I didn't put in any load or anything like that, and I should have 4 volts peak, and we have 1 volt per division, and all that is pretty much fine. So since this scope can go really, really fast, you will find these input 50 ohms. So there's a built-in load. So now I put in a 50 ohm here. And then of course I need to go on my signal generator and put in 50 ohm right there. And then I can again say 4 volt peak peak. And there you have it again. And now we are compensated for the cable and everything, and we should be able to go much faster. I think I'll go down in volts because I think we're gonna crank up the speed. So this is a 1 volt peak peak, and we have 200 per division. So let's see here. So that is also perfectly fine. All right, so this scope is of course full of all sorts of cool features for 93. I mean, before that you had to count the divisions, figure out your sweep speeds, and then calculate the frequency and all that kind of stuff. But here we got the measurements, and you can just hit time and then say, oh, I want to measure frequency, and then automatically sets up everything. There's no poking around with cursors and all that kind of stuff. Of course, you can go into cursor mode if you want that. So here it says 1 kilohertz more or less. If I want the time instead, I can just, okay, measurement is already active. So it just shows both the frequency and the, okay, I have an idea. Let's try and clear this and say, okay, I only want, yeah, okay, so you can do that. That's funny, I cannot. Okay, so it's duty cycle. Can also have duty cycle. And then you can clear it. Next menu. What else do you want? I mean, rise time, fall time, and la 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 la. It's, yeah. I really like the way that this scope works. It's super simple. Not too many features and not too few features. It's doing exactly what you need, really. So now we're gonna try and crank up the frequency. So try and remember the divisions we got here, right? So this is 1 kilohertz, which is gonna crank it up to 10. Didn't see any difference. And then of course we should crank up the speed here, and then we are back again, right? And let's go 100 kilohertz. That is not super interesting. We should see exactly the same. So that will be the first megahertz. And you'll start to see some funny things. So that is 10, 20, see? It's blinking here, so it's doing some funny things. So this is 100. And remember, this is a repeating signal. Now you can start to see it's doing some funny blinky blink here. And this is because it is time moving the trigger and the memory, and this way adding all the dots in the samplings and get all this really nice resolution in 100 megahertz. So let's try 200, 300, 400. And yeah, you'll see that we have how much, oh, we have full speed here. So this is 400, let's try 500. And now we should have about half of the readout. So that is the bandwidth of this oscilloscope. And it's doing pretty fine. This is a sine wave signal. So I'll go, oops, I also moved the level of my, that is not good. We're back again. Okay, so let's try something funny. So here is a pulse. This is a 100 nanosecond wide, and I repeat this only 10 times a second. So it's really, and the idea is, if I go into single mode, you will see the points this scope really have at this speed. Obviously, there's this big distance between the samples. So this is about 100 nanosecond between the samples. No, it's 50, right? See, this is 50 per division. So, but the pulse that I have is 100, but that is the way that this scope will see this signal with the way that it's sampling, right? But if I put it into normal mode, you will see what happens. It will build up a curve with my pulse with much higher resolution because my pulse is repeating, and it's exactly the same pulse that is repeating. So it can build up, as you can see here, it builds up a higher quality image of that pulse. And if we wait long enough to have achieved enough samples, we will see that we will get a nice square signal. Of course, what if this signal only comes one in a lifetime? I mean, you only have it once. Yeah, then it will really look that bad in those higher speeds here. But this is only a 100 nanosecond pulse. It's really not, as you can see here, a lot of something, right? Normally, when I test scopes, I really like this 1 microsecond pulse, and then I can of course repeat it faster or slower depending on the scope technology. Since this one is a digital, I can of course repeat it real slow. And now you see here that this is a single mode again. Now you see the distance between the samples, that's much closer, and it's still making this vector between the points, and this is in single. So if I go to normal, you'll see again it builds it a little bit better with much higher resolution. So all in all, for signal that is repeating, I think this scope is good for 5 to 10 megahertz pulses, or signals, but not more than that really. I prefer to use it at speeds less than that. And if you have a signal that is repeating, yes, it is right, it will go to 500 megahertz as they claim, but only for one channel, obviously. Everything that I show here is half of that if you enable both of the channels, because then it's going to sample left, right, or 1, 2, 1, 2. I mean, this has no more bandwidth. This is a memory bandwidth issue. So that's how it works. Digital oscilloscopes, I mean, always handle XY mode really bad. But I gotta say that this one is really good for a digital scope. So what I think it does is actually somehow storing or peak holding, sample holding both of the inputs at the same time, and then using its digital system to move those data and correctly and all that kind of stuff. So it is really not causing all sorts of funny problems that I see all the time with the digital scopes. So yeah, it totally works in XY mode. Amazing. And here we go with the 2-channel mode. We have this. Here we go. So that will be the 2 sweeps that we're dealing with. Amazing. This is actually this picture. It's hard to believe, isn't it? There is one more really cool thing I want to show. I mean, this has already been shown in many other videos. So, but I think it's bad if I don't really show this as well. So when you hit the print menu and hit those 2 buttons right away, then you will activate a little hidden game. So there's a Tetris game in here. So push this, and then here you go. Now you have, and then you can play the Tetris game, and then you can just advance, and it is a fun little game. If you don't have anything cool to do in your working hours, I don't know, then you can play this. It's funny, you can move it. I mean, when it's touching the bottom, you can still move it. So that's yeah, a little hidden Tetris game. Funny they had time to put this in. I mean, somebody programmed this in the working hours, right? Instead of improving or adding other useful features, they really made this, and I think it's fun. And if you die, game over like that, then there will be, I think there will be new high score. So where is the high score? If I just put in something like that, done. Oh, nobody ever played the game. See, the high score was completely empty. I think you can just quit the game and then it will reboot. Yeah, reboot the scope, and yeah, we have done again. How cool is that? In case you need to know how to remove the options or upgrades, you can have all sorts of serial parallel ports and all that kind of stuff. And the idea is you of course unscrew this one, but you pull it from the bottom and then it should go like that. You cannot pull it from the top, you're gonna break these little plastic hinges. So you stick it in and then put it in the connector, okay? It's quite easy to open, just a few screws here at the back and then slide the cover out. And you can find this little sticker here at the side. This will show, yeah, reveal the age. So this one is from '94. And the power supply is also rather modern for its time. There's the control and regulation board here with the optocouplers and all that. That's a little SMD board, while the rest is of course through-hole components. I didn't find any reefer capacitors in this one. Then that's a little bit what I was scared about. I always recommend you inspect those capacitors around here, but those are not reefer, so we can be quite happy. All is fine. What is that? Oi, oi, oi. I am not happy about that. So that is a long, deep, nasty scratch. Or is that some... What exactly is this? How is that done? Lucky we don't have any components. I don't know exactly what to say about that track here. I don't know, can you see what I'm saying? Got some tracks here and this is on the next layer, right? So this is a multi-layer board, and the routing is a little bit random, funny. I would expect this to be super duper computer. Hello, why are you good? Thank you. And that is of course the little CRT module with this thin cable for both power and video. And I think all you have to do is just pull, yeah. Then you can take the shield away, and there shouldn't be any screws or anything. But no, not with one hand. And that will be the beautiful CRT module. Through-hole components all over the place. And it's got its own little power supplies and all that. But that's pretty much what we expected. This is a magnetic deflected CRT, and it's yeah, quite high resolution, and and all that. Or sometimes you also find manufacturing dates on CRTs. So from the side we can show the main board, and it is a double populated board, so we got components on both sides. Just the more simple components like capacitors and all that kind of stuff. Not a whole lot of ICs and all the big complex stuff. That is kept on this layer. It's really a beautiful layout, and we can see the grounds between the layers for the digital stuff, and we got some other ground planes here, and then it's probably another ground plane that's looking a little bit different, right? Some different layers and all that. Yeah, quite a lot of layers, probably 8. And yeah, a lot of HP special components. Motorola parts, we see more HP special parts. So that will be the 2 channels and the trigger. And that is maybe a special part handling the inputs, right? And that will be memory. And got some really funny thing going on here. This is the microcontroller 68HG000. Almost like an Amiga. And 2 times 8-bit EEPROMs for the program memory. But this one is a little bit concerning. This thing here is a lithium battery 0 power RAM. So that will be all your settings, all your high scores for your Tetris game and whatnot. That will be stored in this lithium battery. And yeah, it contains RAM and all that kind of stuff. I've seen people kind of grind their way through this to replace the battery inside here, and that should be done before it leaks. I can't remember if there is a voltage measurement point for this one, otherwise we just need to wait until it fails. So that could be a little bit of a problem. 40 megahertz oscillator right there. So this one, this is a 10 megahertz maximum. So it's probably using the 40 megahertz for some other timing and stuff. But I think this is more or less all the nice and fantastic things you will find inside this beautiful old HP scope. Wow, a lot of tantalum capacitors all over the place. I'm not a super fan of those, by the way, but that is just how it is. Ooh, a little crystal here and a PLL making a lot of fast clocks. And we also find some RF connectors, most likely for some of the really fast signals. See, we got some AD stuff here, right? Yeah. There's actually one little thing that I found while going through this unit. I don't know if this... Yes? Can you see this area here? It looks a little bit like something leaked. There's another little thing that I want you to know. Those rubber plastic feet here, sometimes they just go into dissolve and splat the whole thing into a big nasty mess mode. So you need to inspect they are good and fine. And also I find another nasty crack here on the side, and that I did not see on the outside. Hey, how bad is that?